Hello, good evening, everyone. Can everyone hear me? Shamita, Anandit, Raktim, tell me.
Good evening, sir.
Yes, Devang, can you hear me? Okay. So let us start. Yesterday we were doing binomial. Okay, so let us continue. Can everyone see my screen? Okay. So these were the last problems we had done up to question number 8. Okay, let us do some more problems. Okay, everyone solve. These are the first two questions of today. Question number 1 and 2. This is question number 1, question number 2. Quickly solve. Once you have done it, send your answers. After this, question number 3. Root 3 plus 3 whole to the power 5 minus root 3 minus 3 whole to the power 5 is equal to question mark. Question number 4. In the expansion of 1 plus x whole to the power 10, the coefficient of 4r plus fifth term, the coefficient of 4r plus fifth term is equal to coefficient of 2r plus 1th term is equal to coefficient of 2r plus 1th term. Find r. Question number 5. Yes, first one is done. Tell me, everyone.
Sir, please wait.
Quickly solve. Find the greatest value of term independent of x of x in the expansion of x sine alpha plus cos alpha by x whole to the power 10 for all alpha belongs to R. Solve. Yes, Raktim has sent the first one. Let's see. Raktim, what is the final answer? I didn't get the final answer only. I need the final answer.
Sir, actually, I was getting two answers.
How can there be two answers? There will be only one x to the power 5, isn't it? There will be two x to the power 5 or only one x to the power 5. Okay, let me solve first one.
1 second, I did a mistake.
Sir, I've sent the first one.
I'm checking. Everyone, I need the final answer. Yes, Devant, your answer is correct. So everyone pay attention. Number one. Anandit, Socrates, Shomita, pay attention. And Raktim. See, over here, we need to find out the coefficient of x to the power 5 in 1 plus x square whole to the power 5 into 1 plus x whole to the power 4. So everyone, what is 1 plus x square whole to the power 5? It will be 1 plus 5c1 into x square plus 5c2 into x to the power 4 plus dot 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 dot. Okay, Shomita, check your answer again. Multiplied by 1 plus x whole to the power 4. So 1 plus 4c1 into x plus 4c2 into x squared plus dot 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 dot. So everyone, how are we going to get? See, when you multiply these two expressions, how are we going to get x to the power 5? Tell me. By multiplying 1 with any of them? No. Why? Because over here the highest power is x to the power 4. Right. So over here x square has to be multiplied to x cubed. So coefficient of x to the power 5. Shomita, are you getting? Tell me.
Sir, can you show question number 3 once?
Yes, wait. Coefficient of x to the power 5. See, Shomita, when we multiply x square with x cube, then we are going to get x to the power 5, right? Which will give us 5c1 into what is the coefficient of x cube? Shomita, over here. Over here, what is the coefficient of x cube?
4C3.
4c3. Next. Raktim, over here, when we multiply x to the power 4 with x, then we are going to get x to the power 5. So plus 5c2 into 4c1. Now tell me, Raktim, will I get any other way? In any other way, will we get x to the power 5? Tell me. Is there any other way we can get x to the power 5? Tell me.
Sir, 5C3 into 1.
5c3 into 1. Over here, 5c3, it will be x to the power 6, not 5.
No, sir, then.
There's no other way. So what is the answer? 5 into 4, 20
60,
plus
sir, I think.
40 is equal to 60. Right. Socrates, you got the correct answer. Tell me, Anandit, is it clear?
Yes, sir.
And Raktim?
Yes, sir.
Okay. Move on. Solve number 2 quickly. And this type of questions have come this year also in mains. You check. In this year JE mains, this type of questions have also come. I mean, solve quickly.
Sir, I've
Yes,
sent you the second question. Did you receive it?
yes. Chocolate number 2 is correct. Devang, number 2 is correct. Shaumita 2 is correct. And who else is left? Okay, Raktim, I'm solving. Raktim and Anandit. I'm solving this one. Only Raktim and Anandit is left, I guess. Let's see. Yes. So Raktim and Anandit, I'm solving this one. We need to find out the value of 1 plus root 2 whole to the power 7 plus 1 minus root 2 whole to the power 7. So it's just like we have to add. We have to write down the expansion and we have to add. Okay, we just had to write down the expression and then we have to add. Yes. Anandit, how much are we getting? This is not the answer. It will be 1 plus.
No, 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 sir. I'm writing the question. Like I'm giving you the answer right now.
Oh, you're giving the answer. Send quickly. And I think Raktim is also there. So Raktim, I'm solving. Raktim, pay attention. It will be 1 plus root 2. Yes, Anandit, right answer. 1 plus root 2 whole to the power 7 will be equal to 7c0. That is 1 plus 7c1 into root 2 to the power 6 plus 7c2 into root 2 to the power 5
5 in.
plus dot.
Huh.
Achha, sorry, root 2. Then root 2 squared plus dot plus 7c7 into root 2 to the power 7. Tell me, are you getting?
Yes, sir.
Raktim? And 1 minus root 2 whole to the power 7 will be equal to 1 minus 7c1 into root 2 plus 7c2 into root 2 square minus 10 dot. Lastly, it will be 7c7 into root 2 to the power 7. Raktim, if you are having any doubt, you can ask me. Tell me.
No, sir.
No. Then when you add, so Raktim, what will happen? All the middle terms are getting cancelled, right? All the
Yes.
odd power terms. So what are you getting? 2 into 1 plus 7c2 into root 2 square. That is 7c2 will give us how much? 7 6 of 42 divided by 221 into 242 plus 7c4 into root 2 to the power 4. 7c4 will give us how much? 7c4 is 7 into 6 into 5 divided by 1 into 2 into 3. That is 35. So 35 into root 2 to the power 4. So 35 into 4 will give us how much? 140. And then 7c6. 7c6 is 7. 7 into root 2 to the power 6 is 8. 7 into 8, 56. Tell me, are you getting Raktim?
Yes, sir.
This calculation, you can do it very easily. You will get the answer as 478. Is it clear, Raktim?
Yes, sir.
Quickly solve number 3. Yes, Socrates, number 3 is correct. Devank, wait a minute, what have you written? Yes, Devank, number 4 is correct. Shomita, check number 3. 3 is the, 3 is similar to number 2. I mean, same as number 2 almost. So over here we need to subtract. Yes, Devank, number 3 is correct. Shomita, check number 4. Shomita, instead of adding, instead of subtracting, did you add in number 3? Check. I think you are making some
Yes,
mistake.
sir. Yes.
Yes. By the value, I understood. What did you do? What mistake you have done? Anandit, number 3 is correct. Raktim, quickly solve number 3.
Yes, sir. Solving, sir.
Improve your speed. It is important. Nowadays, improve your speed. It is important. Quickly. Okay, I'm solving this one. We have to find out root 3 plus 3 whole to the power 5 minus root 3 minus 3 whole to the power 5. So let us start. So what I'm going to do is I'm going to take root 3 to the power 5 common. Pay attention. This is number 3. Okay, can you simplify this? Actually, Raktim, I've got a simplified answer.
Yes, it's simplifying 1/7.
Okay. So Shomita, I'm solving this one. You see what do we get? You take root 3 to the power 5 common. Within brackets 1 plus root 3 whole to the power 5. Right, Shomita? So this will
Yes.
become root 3 to the power 5. Within brackets 5c0 plus 5c1 into root 3 plus 5c2 into root 3 square plus dot 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 plus 5c5 into root 3 to the power 5.
So
Root
can you
3 to
show
the power
question
5.
number 4 once? I just need to see one line.
Yes.
Okay, sir. Thank you.
Yes. So what do we get? We'll get root 3 to the power 5. We'll get same thing, but with alternately positive, negative. Right, Shomita, are you getting?
Yes, sir.
Okay. And then when you subtract, you have to subtract, remember? When you subtract, all these terms will get cancelled. Acha, wait. It should be alternately positive, negative, positive, negative. All the odd power terms will remain. Okay. Next. So what are you getting? You are going to get root 3 to the power 5 within brackets 5c1 into root 3 plus 5c3 into root 3 cubed plus 5c5 into root 3 to the power 5. Right, tell me, are you getting? Shomita?
Yes,
And
sir.
what are we getting? Root 3 to the power 5 is 9 root 3. 9 root 3 within brackets 5 root 3 plus 10 root 3. 10 into 3, 30 root 3 plus 5c5 is 1 and root 3 to the power 5 is 9 root 3. Okay. This we have to multiply by 2. Right. Since we are adding the same terms twice. So this will give us how much? 5 root 3 plus 30 root 3 plus 9. This will be 44 root 3. 44 into 9. So I'm getting 44 into 3 into 9 into 2. Are you getting, Shomita?
Yes, sir. Yes.
When you simplify, this will give us 88 into 27. This will give us 2376.
Yes, sir.
Okay. Done. Raktim, you have also got the same answer, right?
Sir, not. I might make some calculations.
Okay.
But sir, I
But
am
I hope
doing
you have understood.
that process only.
Okay. Yes, Devang, number 5 is correct. Socrates 4 is correct.
Can you show the 5th question, sir?
Okay, quickly solve 4 and 5, everyone. Should I start 4, everyone? Tell me. Who is left? Raktim, Anandit, and Shamita. Should I start? Tell me. Okay, let us start. Number 4. It is written in the expansion of 1 plus x whole to the power 10. The coefficient of 4r plus 5th term is equal to coefficient of 2r plus 1th term. So you people tell me. What is the coefficient of 4r plus 5th term? What is the coefficient? Tell me. What is the coefficient of 4r plus fifth term? 10c, 4r plus 4? Yes or no? Tell me. Raktim, Shomita, Anandit, yes or no?
Yes, sir.
Yes, sir.
Okay. Shomita, if you have any doubt, you can ask me. You understood, right? How I got 10c 4r plus 4? Tell me.
Sir, can you explain it once?
Yes. So why are you not asking? Tell me. Shomita. Hmm? If you have not understood, why are you not asking? It should be t 4r plus 5 is equal to t 4r plus 4 plus 1. Are you getting? Do you
Yes, sir.
remember? So are you able to relate? Are you able to relate it with tr plus 1?
Yes, sir.
So now is it clear? How are we getting 10c 4r plus 4?
Yes, sir.
Tell me. If you still couldn't understand, you can ask me. Tell me, Shomita.
Yes, sir. Understood.
Understood, right? Okay. Socrates, check number 5. Tell me, Raktim, do you understand?
Yes, sir.
So Raktim, tell me what is the coefficient of 2r plus 1th term? That is t 2r plus 1. Tell me. What is the coefficient? Raktim?
Sir, 10C2R.
10c 2r, absolutely correct. And they both are equal. Right. This implies 10c 4r plus 4 is equal to 10c 2r. Tell me, how will we calculate? Tell me. This implies 4r plus 4 is equal to 2r. Right, tell me.
Yes, sir.
Or there is another possibility. Tell me, what is the other possibility? Shomita, Raktim, can you people tell me? Anandit, can you tell me?
Sir, 2R plus 4R plus 4 equal to 10.
Absolutely correct. 2r plus 4r plus 4 equal to 10. Right? This implies from here we are getting r is equal to minus 1, which is not possible only. Right? Tell me, everyone. This is not possible. No, r equal to minus 2, I guess. R equal to minus 2, which is not possible because r has to be a natural number. Or over here we are getting 6r is equal to 6, r equal to 1. Okay, this will be the answer. Tell me, Raktim, Shomita, Anandit, is it clear?
Yes, sir. Yes, sir.
Okay. Quickly solve number 5.
Sir, I wrote the power of the last question as 6 instead of 10.
Oh,
I'm
rectify,
sending
rectify.
all.
Okay. Okay, everyone, should I start number 5?
So just wait for one moment.
Okay. Yes, Socrates, your answer is correct. So only Raktim, Anandit, Shomita, these three people are left. Okay.
Sir, 1 minute.
Quickly solve. No, Shomita, you are making a mistake. First of all, you find out the term independent of x. See, it is written x sine alpha plus cos alpha by x whole to the power 10. So find out the term. They are asking us the term.
Yes, yes, sir.
Whichever term is independent of x, you have to find out the greatest value of that term. Okay, Shomita. Yes, Anandit, right answer. Raktim, check your answer again. Okay, so Raktim and Shomita, pay attention. We need to first of all find out the term independent of x. So tell me, which term will be independent of x? Over here, which term will be independent of x? This is number 5. As you can see, that coefficient of, general term, tr plus 1 is equal to 10 cr.
Sir, is the answer 10c 4 by 2?
No. X sin alpha whole to the power 10 minus r into 1 by, cos alpha by x whole to the power r. So what is the coefficient? What is the power of x? Tell me.
Sir,
What is the
10
power of x?
minus r.
10 minus 2r. This should be equal to 0, right?
Yes, sir.
For term independent of x, 10 minus 2r should be equal to 0. So what is the value of r? Tell me.
5.
5.
Fine.
That means T6. T6 is independent of x. So T6 is equal to 10c5 x sine alpha whole to the power 5 into cos alpha by x whole to the power 5. If you people are having any problem, let me know. Tell me. Shwamita, Raktim, any problem? Tell me.
No, sir.
Shwamita, tell me.
No, sir.
So what are we getting? 10c5 into sine to the power 5 alpha into cos to the power 5 alpha. You people know how to find out the greatest value of this trigonometric expression.
Sir, is the answer 10c5 by 2 to the power 5?
Correct.
So can you show how to find out this greatest value?
Yes. Shwamita, what you do is, you first of all multiply them. You'll get sine alpha into cos alpha whole to the power 5, right?
Yes, sir.
And then your task is to convert this into a single trigonometric ratio. Okay. So Shwamita, can I write it as 10c5 into 2 sine alpha cos alpha? You know, right? What is 2 sine alpha cos alpha?
Yes, sir.
What is 2 sine alpha cos alpha? Tell me. Shwamita, what is the value of 2 sine alpha cos alpha?
Sir, I forgot it.
Oh God. Revise trigonometry again, Shwamita. If you need any help, let me know.
Okay, sir.
Have I sent you any drive link where all the
Yes,
previous
sir.
notes are there?
Yes,
Go
sir.
through them. There are trigonometric. I have done trigonometric identities also. So you are going to get sine to the power 5 2 alpha by 2 to the power 5. Are you getting, Shwamita?
Yes, sir.
Now, Shwamita, what is the maximum value of this expression? Maximum value of sine 2 alpha whole to the power 5 is equal to 1. Right. Maximum value of sine x is equal to 1 only, right?
1. Yes, sir.
Okay. So maximum value will be equal to, greatest value will be equal to 10c5 divided by 2 to the power 5. This will give us 252 by 32. Okay, let us calculate. This will go by, I guess 4 times 8, 4 times 63. 63 by 8 is your answer. Tell me, Shwamita, is it clear?
Yes, sir.
Okay, and Shwamita, cover your backlogs, whatever you are left. Okay, and if you need any help, let me know. Okay,
Yes, sir.
okay. Next, another few more questions. Again, pay attention. Okay, these are 6 and 7, everyone. Quickly solve. Take your time. Don't make a mistake, everyone. Question number 6 and 7. Solve. Okay, should I start, everyone? 6 part 1? Yes, Dr. with right answer. Everyone tell me. Yes, so, Raktim, your answer is correct.
Sir, please wait.
This question is like, what to say? It's very conceptual. Pay attention. What are the terms given to us? It's very conceptual. Just try to expand, you will understand. Yeah, Devank, your answer is correct. Okay. So Anandit and Shomita, pay attention. Yes, Anandit, right answer. Yes, Shomita, right answer. Actually, Anandit, can you explain your answer a little bit? I mean, couldn't understand. You wrote r equal to 0. What is the meaning of r equal to 0?
Sir, sorry, the number of terms here will be 0.
Number of rational terms will be equal to
Yes,
0,
sir.
right?
Yes, sir. Yes, sir.
Okay,
So
okay.
actually, the R it was like when I did it, it was coming both even and odd at the
Mhm.
last stage. So it is not possible.
Exactly. I mean, both the terms, both the powers has to be even, but even
Yes,
plus
sir.
even can never be equal to 15,
Yes, sir.
right? You people also have used the same logic, right?
Yes, sir.
Okay. Quickly solve part 2. Yes, Socrates part 2 is correct. Raktim, check part 2. Devon, check your answer again. Okay, let me start with 6 part 2. It's 4 to the power 1 by 3, 1 plus 1 by 6 to the power 1 by 4, whole to the power 20. Let us start. Yes, Anandit, right answer. 4 to the power 1 by 3 plus 1 by 6 to the power 1 by 3, 1 by 4, whole to the power 20. So over here, what is TR plus 1? TR plus 1 is equal to 20 CR into 4 to the power 1 by 3, whole to the power 20 minus R into 1 by 6 to the power 1 by 4, whole to the power R. Okay. Acha. Over here, to get a rational term, to get a rational term, 20 minus R should be a multiple of 3. Should be a multiple of 3. And R should be a multiple of 4. multiple of 4. Okay. So you people tell me. If r equal to 0, what is 20 minus r? 20 minus r is equal to 20. Is it a multiple of 3? Tell me.
No, sir.
No, it's not possible. Which is not a multiple of 3. Right, Devang, Shamita, are you getting? Next. We can start with 4 because we only have to take multiples of 4. So if r equal to 4, what is 20 minus r? 16. So is it a multiple of 3? Tell me. If r equal to 4, is it a multiple of 3?
No, sir.
No. So Shamita, can you give me an example for what value of r? 20 minus r will also be a multiple of 3. Shamita? Hello.
Yes, sir.
Tell me for what value of r? 20 minus r is also a multiple of 3. Tell me.
Sir, if r equals to 5, then it is a multiple of 3.
Shamita, you are not paying attention, right? Properly. Tell me. Or you are having some issues.
R should be
Why
multiple.
why did you take r equal to 5?
No, sir, no, sir. R should be a multiple of 4, so uh,
Tell me, go on. Shamita cannot understand. Like, why are you taking so much time?
So
R
can you
should
tell
be a
the
multiple.
question number, last question number?
Last question
sir,
number is
R
7.
equals to 8. We can check once with that.
If r equal to 8, what is 20 minus r?
It is 12.
12. Is it a multiple of 3?
Yes, sir.
Yes. So this case we can take,
Yes, sir.
right? Why is it taking so long? Cannot understand. Are you doing something else also behind the screen?
No, sir.
Sure.
Yes, sir.
Okay, pay more
Sir,
attention.
I was also solving the problem once.
Okay.
Sir, but I only got r equals to 8 as the only valid case, so the answer should be 1.
Okay. Raktim, can you tell me, is there any other value?
Sir, I also got only 8.
Sir, if it is
What?
20,
Very good. Very good. This is what I wanted to hear. If r equal to 20, is 20 minus r a multiple of 3? Tell me. 20 minus r is 0. It's also a multiple of 3. Are you people getting? So hence, there are two rational numbers, two rational terms. Is it clear? Raktim,
Yes, sir.
Devang?
Yes, sir.
Yes, I forgot to include 20.
Okay. So number of rational terms is equal to 2. And if I ask you what is the number of, so if I ask you what is the number of irrational terms, can somebody tell me, raise your hand. What will be the number of irrational terms in this situation,
Total
in this
number of
question?
terms minus 2.
Yes, correct. So tell me the final
21
answer.
minus 2, that is 19.
19. Right, tell me, Raktim, Anandit, Shamita, and Devang.
Yes, sir.
Okay.
Yes, sir.
Quickly solve. Number 7, quickly solve. Yes. Socrates, your answer is correct. Others also quickly solve. Okay, everyone pay attention. In the expansion of 1 plus 1 plus x plus 1 plus x square plus dot 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 1 plus x whole to the power 19. Okay, what do you think this looks like?
GP.
Tell me. GP? Are you people able to identify GP? If you are unable to identify GP, practice more at home. 1 plus x whole to the power 19. Okay, the series is in GP, right? First term is given. Common ratio. Anandit, can you tell me what is the common ratio over here? Tell me, Anandit.
So 1 plus x.
1 plus x. So it will become 1 plus x whole to the power 20 minus 1 upon 1 plus x minus 1. Done. This will give us 1 plus x whole to the power 20 minus 1 upon x. Okay. What do I need? What do I need? Over here it is given. The coefficient of x to the power p is the greatest. Okay, coefficient of x to the power p should be the greatest. Over here, when you expand, you're going to get 1 plus 1 plus some 20c1 x plus 20c2 x square plus dot 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 minus 1 plus 1 minus 1 will get cancelled divided by x. Acha, you people tell me among 20c1, wait a minute, what did I do? Where is it? Among 20c1, 20c2, 20c3 dot 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 20c20, which one is the greatest?
So 20
20c 10 x to the power 9. X to the power 10, sorry.
10. Are you getting? Over here, the greatest binomial coefficient. Greatest binomial coefficient is equal to 20c10. Okay. So what is the term? So the term is 20c10 x to the power 10. But it is also divided by x. Right? Tell me. Okay. It is also divided by x. Okay. So here we need the coefficient of. So here we actually need the coefficient of. I mean, over here, coefficient of. We need to find out the coefficient of x to the power p plus 1 In the
So can you
numerator
say
to be the
something?
greatest. Wait. In the numerator. Okay. So everyone, what is p plus 1? So p plus 1 is equal to 10. This implies p is equal to 9 because it is divided by x. Yes, Sakura, tell me.
No, nothing. I was just saying that we could have cancelled out x. Like I did it by cancelling out x, and then same thing. Okay. Just
Same.
in my case, it was p plus 1 equal to 20/2. I mean,
Correct.
same thing. P equal to 9.
Okay. Tell me. Shaumita, Raktim, Anandit, Devang. Is it clear? Tell me. If there's anyone who couldn't understand, you can ask me now. Next. See, our next topic is very important. Okay, everyone. Questions do come from here, from this part in JEE mains, in WB joint also. Okay. In fact, in advance also it has come. Okay. But nowadays they don't ask, but it has come. Okay. Pay attention. Okay. Binomial coefficient. Problems on binomial coefficient. Problems on binomial coefficients. Question number 8. Okay. Show that. Question number 8. Show that C0 square plus C1 square plus C2 square plus plus Cn square is equal to 2ncn.
So C0
Okay.
means NC0, right?
NC0. Okay, over here C0 means NC0. We need to show that this. Okay, so I've got two methods of proving this one. Okay, everyone? Let us see the proof.
So was this a question or an example?
Example, I'll do it. I'll do it. The rest of the problems you will do it. Okay, proof method 1. Using combinatorics. Okay, everyone? Using combinatorics, I'll prove it. Pay attention. Okay? Pay attention, everyone, because the other proofs you people have to do it. Okay. So suppose we need to select. Suppose we need to select n students. Suppose we need to select 10 students of a class. Suppose we need to select 10 students of a class out of n boys and n girls. Okay. So tell me, what is the total number of ways to select n students? Number of ways to select will be
2NCN.
2ncn. Okay. Next. But it can be done in some other ways also. Okay. It can be done in some other ways also. In the first column, I'm going to write down ways to select. Ways to select. Wait a minute. Selections. And on the right hand side, I'm going to write down ways to select. Selections and ways to select. So everyone, it can happen that you have selected 0 boys plus all the girls. Okay, 0 boys plus all the girls. In how many ways can we do this? Tell me.
1.
C0 into Cn. Right, tell me. Everyone. 1 only, but C0 into Cn, yes or no? You'll select 0 boys and all the girls. Next. Or it can happen that you have selected 1 boy and n minus 1 girls. In how many ways can we do it?
C1, CN minus 1.
C1 into Cn minus 1. Right, tell me. Next, it can happen that you have selected 2 boys and n minus 2 girls. Okay. It can be done in C2 into Cn minus 2, dot, 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 dot. It can happen that you have selected n boys and 0 girls. This can be done in Cn minus Cn into C0. Okay. So these are all possible cases, all possible ways to select n students of a class, right? Is there any other possible way? Tell me. Have I mentioned all of them? Tell me.
Yes, sir.
Okay. So either case one will happen, case two will happen, or nth case will happen. So when you add, what are you getting? You are going to get C0 into Cn plus C1 into Cn minus 1 plus C2 into Cn minus 2 plus dot 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 Cn into C0. This will be equal to 2n Cn. Right? Both are same. Okay. Now what is Cn, everyone? Can I write Cn as C0? Tell me, everyone. Can I write Cn minus 1 as C1?
Yes, sir.
Can I write Cn minus 2 as C2? Tell me, has everyone understood the proof? Shomita, Raktim, Devank, Anandit?
Yes, sir.
Okay. This implies C0 square plus C1 square plus C2 square plus dot 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 plus Cn square is equal to 2n Cn. If there's anyone having any doubt, you can ask me now. Hence proof. Socrates, is it clear properly?
Yes, sir.
Okay. Method 2. Method 2 is using binomial. Okay. Method 2 is also important because there are some cases, okay, where using combinatorics will be difficult. I mean, not difficult, but complicated. Okay. Next, method 2. What I'm going to do is, first of all, I'm going to write down the expansion of x plus 1 whole to the power n. X plus 1 whole to the power n will be equal to C0 x to the power n plus C1 x to the power n minus 1 plus C2 x to the power n minus 2 plus dot 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 plus Cn x to the power 0. And what is 1 plus x whole to the power n? This will be equal to C0 plus C1x plus C2x square plus dot 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 plus Cnx to the power n. What I'm going to do is I'm going to multiply these two equations. This is equation 1. This is equation 2. Okay. Multiplying equation by equation 1 and equation 2. On the left hand side, we are going to get x plus 1 whole to the power 2n. This will be equal to C0 x to the power n within brackets, this whole thing. Within brackets, this whole thing. Tell me. Next, plus C1 x to the power n minus 1 within brackets, this whole thing. Okay. Plus C2 x to the power n minus 2 then brackets, this whole thing. Right. Devang, are you getting?
Yes, sir.
Raktim and Anandit.
Yes, sir. Yes, sir.
Okay. Plus dot dot dot. Okay. Last term will be Cn into this whole thing. Okay. Okay. On the left hand side, whose coefficient is 2n Cn? Tell. I mean, what is the term whose coefficient is 2n Cn? Tell me. Tell me. Whose coefficient is 2 NCN? What is the term whose coefficient is 2 NCN? Tell me.
Sir,
Everyone?
2
What is the power
NCN,
of x?
x to the power n, 1 to the power n.
Exactly. So x to the power n, right? So
Yes,
everyone,
x to the power n.
what is the coefficient of x power n in x plus 1 whole to the power 2n, which is equal to 2 NCN. Right. Next, what is the coefficient of x to the power n on right hand side? Okay, let us see how it is forming. So everyone, coefficient of x to the power n, it is C0 into C0. Right, tell me everyone. Then C1 into C1, then C2 into C2, then C3 into C3, then Cn into Cn. Are people getting? If you couldn't understand, you can ask me. Plus dot 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 plus Cn square. Okay, hence proved. Tell me. Raktim, Anandit.
The last person.
I mean, how are we getting coefficient of x to the power n in the right hand side?
Yes, sir.
Okay. So see Raktim. Over here, what is the coefficient of x to the power n? C0 square.
Yes.
Over here, C1 square. Over here, C2 square. Dot 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 dot. Over here it is Cn square.
Yes, I understood.
Understood? Shamita, is it clear properly?
Yes, sir.
Okay. Next. Next one is also very important, everyone. Very, very, very important. Okay. If you remember this, you can do, I mean, if the question comes on binomial series, you can solve it within seconds. That is Vandermonde's identity. If the question comes on binomial series, you'll be able to solve it within seconds if you remember this identity, Vandermonde's identity. Pay attention. Summation of k equal to 0 to r mck into ncr minus k. This will be equal to m plus n cr. How to remember this? You see, you have to add the upper suffix m and n, and you have to add the lower suffix k and r minus k. Understood, everyone? Tell me. If it is
Yes,
given
sir.
summation of k equal to 0, remember also k should start from 0 and ends in r. So from k equal to 0 to r, if it is given mck into ncr minus k, this will be equal to m plus ncr. Okay, let us see the proof. Okay, first of all, I'm going to show you the proof with combinatorics. Okay, everyone. Let us see the proof with combinatorics. So over here, suppose, remember how to prove with combinatorics. We are selecting R students. Suppose we need to select R students. Out of M boys and N girls. Okay. So what is the number of ways to select? Tell me. What is the number of ways to select? R students out of M boys and N girls. In how many can you select? R students out of M boys and N girls.
M plus NCR.
M plus NCR. Okay, everyone. Number of ways to select R students out of M boys and N girls. Tell me, Raktim, Anandit, Devank, are people getting it?
Yes.
Hello. Shamita, are you getting?
Yes, sir.
Okay. In how many ways can we do it? The first column, I'm going to write down type of selection. And in the second column, I'm going to write down ways to select. Okay. So type of selection. Either you can select 0 boys plus R girls. In how many ways can we do this? Tell me. You are selecting 0 boys and R girls. Tell me, everyone. In how many ways can you do it?
Sir, MC0 and NCR.
MC0 into NCR. Next. Or you can select 1 boy and R minus 1 girls. In how many ways can we do it?
C1 into NCR minus 1.
MC1 into NCR minus 1. Okay. Or dot 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 dot. It goes on like this. R boys and 0 girls. This can be done in MCR into NC0. Okay. So these are the all possible cases. Is there any other possible cases? Any other possible case we should take? Tell me. Any other possible case we should take? Tell me. Hello. What do you think?
No, sir.
No. Right. Devank, are you getting? Okay.
Yes, sir.
So on adding, what do we get? M plus NCR is equal to MC0 into NCR. MC0 into NCR plus MC1 into NCR minus 1 plus MC2 into NCR minus 2 plus dot 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 plus MCR into NC0. Remember. Hence proved. This will be equal to summation of R equal to 0, K equal to 0 to R MC MCK into NCR minus K. Hence proved. Is it clear to everyone? Vandermonde's identity. I've done it using combinatorics.
Yes, sir. Clear.
Okay. Raktim, Anandit, Tevank, Shamita, is it clear?
Yeah.
Yes, sir.
Method 2 using binomial. So x plus 1 whole to the power m, I'm going to multiply with 1 plus x whole to the power n. Similar type of proof. X plus 1 whole to the power m will be equal to mc0 x to the power m plus mc1 into x to the power m minus 1 plus dot 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 plus mcm. And over here, nc0 plus nc1 into x plus nc2 into x square plus dot 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 plus nc n x to the power n. When you multiply, multiplying equation 1 with equation 2, you are going to get x plus 1 whole to the power m plus n. This will be equal to mc0 into x to the power m within brackets, this whole thing. Okay. Plus mc1 into x to power m minus 1 within brackets this whole thing. Okay. Plus mc2 into x power m minus 2 into this whole thing. Okay. Plus dot 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 dot. Plus mcm into this whole thing. Now, whose coefficient we need now? What do you think? Whose coefficient we need now?
M plus NCR.
That is x to the power r?
So yes, coefficient of x to the power r, that is M plus NCR.
Exactly. So what is the coefficient of x to the power r on the LHS? Coefficient of x to the power r in LHS left hand side will be equal to m plus NCR. And what is the coefficient of x to the power r in RHS right hand side? Tell me. Let us start. Okay, let us start spotting coefficient of x to the power r. Okay, I start from the end. Okay, everyone, I start from the end. So you people see, if I want to find out coefficient of x to the power r, over here, what is the coefficient of x to the power r? Tell me in the brackets. In the brackets, what is the coefficient of x to the power r?
So NCR.
NCR. So it will be MCM into NCR. Yes or no? It is MCM into NCR. Okay. Plus, in the previous one, it will be MCM minus 1. NC. Wait a minute. MCM minus 1 into divided by, wait a minute. MCM minus 1 coefficient will be x, and over here x to the power r minus 1. So NCR minus 1. Okay. Plus dot 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 dot. Okay. It will go on up until MCR into NC0. Okay. Next. So everyone, MCM, we can write it as MC0 into NCR plus MC1 into NCR minus 1 plus dot 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 plus MCR into NC0. Okay, you need to make the sum of all the suffix equal to R. Okay, this is nothing but summation of k equal to 0 to R MCK into NCR minus k. Hence proved. Tell me, have you people understood both the proofs, both the methods? I've done both the methods because the strategy of proving in the second method, okay, is important for some proofs, for some binomial series. Okay. Is there anyone having any doubt? You can ask me now. Tell me, Raktim, Anandit, Devang, Shamita, tell me. You people have any doubt? Sokrit,
No, sir.
tell me, Raktim, Anandit, Devang, is it clear?
Yes, sir. Yes, sir.
Sokrit, is it clear?
Yes, sir.
Okay, if it's clear, let us start. Okay. Show that. You have to send me the proof, okay, everyone? Show that C0, C1 plus C1, C2 plus C2, C3 plus dot 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 plus Cn minus 1, Cn is equal to 2n Cn plus 1. So once you have done it, send your answers. Okay, this is not question 1. This is question number 9. Solve. Then should I start number 9?
Sir, please give some time.
Okay, solve quickly.
Sir, I've sent you number 9.
Yes, Socrates number 9 is absolutely correct.
Sir, I couldn't solve number 9, but I solved 10. Nice and 10.
Send. Okay, I'm starting to solve number 9. Okay, Shwamita, Raktim, Anandit, pay attention. Number 9. So which method you want me to adapt? Tell me. Combinatorics or binomial? Tell me. Shwamita, Raktim, Anandit, tell me. Which proof you want for number 9?
Sir, combi.
Combinatorics. Okay. Yes. Devang, your answer is correct. Okay. I think Shwamita has sent it. Yes, Shwamita, your answer is correct. You can use vandermonde's identity as well. Okay. Pay attention. So, method 1. Okay. C0, C1. Okay. So, over here, suppose we need to select n plus 1 students out of n boys and n girls. Okay. So tell me, what is the number of ways? Therefore, number of ways to select will be how much? In how many ways can you select n plus 1 students out of n boys and n girls? Tell me. Raktim,
2c n plus 1.
2nc n plus 1. Okay. Next. In how many ways can it be done? Okay. Selections. Number of ways to select. Okay. So it can happen that you have selected one boy and n girls. This can be done in how many ways? And C1 into Cn. Next. It can happen that you have selected two boys and n minus 1 girls. This can be done in C2 into Cn minus 1. Okay. Dot. It can happen that you have selected n boys and one girl, which can be done in Cn into C1. So what is the total? Is equal to C1 into Cn plus C2 into Cn minus 1 plus dot plus Cn into Cn C1. This is equal to 2n Cn plus 1. Okay. But what do I need? I need C1 into C0 into C1. So over here, Cn I can convert it into C0. So it will become C0 C1 plus C1 minus 1 I can convert it into C1. So it is C1 C2 plus C2 C3 plus dot 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 plus Cn minus 1 into Cn is equal to 2n Cn plus 1. Tell me, is it clear? Raktim,
Yes.
method 2. Method 2 is using Vandermonde's identity. Okay. How we can quickly do it using Vandermonde's identity. Okay. So over here, what have we got? C0 C1 plus C1 C2 plus C2 C3 plus dot 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 plus Cn minus 1 Cn. This can be written as summation of R equal to 0 to R equal to 0 to N. R equal to 0 to N. If R equal to 0, then it should end with N minus 1. R equal to 0 to N minus 1. C0 into, wait a minute, CR into CR plus 1. Okay. R equal to 0 to N minus 1. CR into CR plus 1. Okay. This we have to convert somehow. Okay. This we have to convert somehow. Can I write it as summation of R equal to 0 to N minus 1? C N minus R into CR plus 1. Okay. Acha, it was NC0 into NCR plus 1. Okay. So when you add, this will be equal to N plus N to N to NC N plus 1. Hence proved. Tell me, is it clear? Using Vandermonde's identities also. Tell me, are you people getting? Raktim,
Yes, sir.
Anandit, Devang. Devang, did you
Yes,
understand
sir.
number 9? And Shomita?
Yes, sir.
Shomita, is it clear? Okay. Quickly solve 10. Yes, Socrates. I'm checking yours. Yes, yes. Socrates, your approach is correct. Quickly solve. Okay, should I start, everyone?
So please wait.
Quickly see. You need you need some coefficient in the in front. So think about it. There are two ways to solve. Shwamita, I want to ask, in the second step, how are you getting r to the power n? This I couldn't understand.
Sir, I made a mistake. I'm doing the correction.
Yes. And after that, how you got summation of, there are too many things you did without explanation. Cannot
Yes, sir.
understand.
Yes, sir. After sending, I'm seeing that there are mistakes in the answer.
No, the answer was correct, but the thing is, there are too many things you did without explanation.
Sending you 10.
Say. Yes, Socrates 10 is correct. Okay. So Shwamita, Raktim, and Anandit, pay attention. No, but why? Like, it's not possible, na? Shwamita, what you wrote?
Yes, sir.
Possible. They both are different variables. And also, r should be less than n. Got it?
Yes, sir.
Okay, I'm solving, pay attention. Okay, you will understand. So there are again two methods to solve. I'll show both the methods. Okay. I'll show both the methods. Pay attention. So method 1. Method 1. What is written? C0 plus 2C1 plus 3C2 plus dot 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 plus 4C3 plus n plus 1 Cn. Okay, so basically you are given summation of r equal to 0 to n rc, sorry, r plus 1 into ncr. Let me see. R plus 1 into ncr. Okay. So over here, can I write it as summation of r equal to 0 to n r into ncr plus summation of r equal to 0 to n ncr. Achha, over here, what is summation of r equal to 0 to ncr? Tell me. What is summation of r equal to 0 to ncr?
2n.
What
2
is the
to the
value?
power n.
2 to the power n. Right. So this becomes 2 to the power n. Right hand side, second term is solved. First term, what I'm going to do is I'm going to simplify this a little bit. This can be written as summation of r equal to 0 to n r into n factorial divided by r factorial into n minus r whole factorial plus 2 to the power n. So over here, this r will go by r minus 1 whole factorial. Okay. Next, in order to convert it into a single term, can you people see that it can be written as n into n minus 1 whole factorial? Tell me. Yes or no? Tell me, everyone. Are you people getting? So this will be equal to summation of r equal to 0 to n into n minus 1 whole factorial upon r minus 1 whole factorial into n minus r whole factorial. Are you people getting? Okay. If it's looking very complicated, let me know. Tell me. If you are having any difficulties in understanding, tell me. I'll explain. Tell me, Shamita, Raktim, Devank, Anandit.
No, sir.
Oh, Devank, you have done it. Tell me. Anandit and Shamita, tell me. You have any doubt?
No, sir.
Shamita? So, Shamita, what will this become? Can you identify? Shamita?
Yes, sir.
N minus 1 whole factorial upon r minus 1 whole factorial into n minus 1 minus r minus
Minus
1
that
whole.
minus 1 whole factor.
So, what is this? Tell me. Shamita,
Yes, sir.
what is this? Tell me.
Sir,
On
n
simplification.
minus 1 c r
N
minus
minus 1. Correct. N minus 1 cr minus 1 plus 2 to the power n. Okay. After this, taking n common out. Okay, n is not a variable, r is a variable. So it is n minus 1 cr minus 1. Now see, but r for r equal to 0, it is not valid only. This binomial coefficient is not valid. So it will start from r equal to 1, r equal to 2, dot, 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 dot. It goes on like this. So it will become n into 2 to the power n minus 1. Right, tell me. Is it clear? N into 2 to the power n minus 1 plus 2 to the power n. So when you take 2 to the power n minus 1 common, within brackets you are going to get n plus 2.
Yes.
Is
Like
it
I
what it is
just
given?
wanted to do like this only.
Okay. But over there were many discrepancies. I couldn't
Yes.
understand many things. Okay, this is what we wanted to prove, hence proved. Tell me, Raktim and Anandit, is it clear? Tell me. Socrates, you have understood this method also?
Yes, sir.
Method 2. Method 2 is also very important and very concrete. Okay, pay attention. So what I'm going to do is 1 plus x whole to the power n is equal to C0
So can you show the last question once?
plus C1x, wait, plus C2x squared plus dot 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 plus Cnx to the power n. Okay. Now over here, I need 1. Over here, I need 2. Over here, I need 3. And dot 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 over here, I need n plus 1. Right, Raktim, pay attention to this method also. This method is also quite interesting. Pay attention. Okay. Done. Socrates?
Yes, sir. Thank you.
Okay. So over here, if I differentiate once, okay, what are you getting? C0 will be gone, but I don't want C0 to be gone. And we are getting 1 into C1, but we need 2 into C1. So in order to get 2 into C1, what I'm going to do is I'm going to multiply by x on both sides. X into 1 plus x whole to the power n is equal to C0x plus C1x squared plus C2x cubed plus dot 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 plus Cnx to the power n plus 1. Now if we differentiate, we are going to get the required coefficients, right? So differentiating both sides. Okay. Shwamita, you know differentiation a little bit or not?
Yes, sir.
Differentiating both sides. Okay, we are going to get x into 1 plus x whole to the power n minus 1 plus over here I have to use UV rule. Shwamita, you know UV rule? Tell me. U
Yes.
dv by dx.
dx plus v du dx.
Exactly. So that's what I'm going to do. X into 1 plus x whole to the power n minus 1 plus 1 plus x whole to the power n minus plus 1 plus x whole to the power n. This is going to be C0 plus 2C1x squared plus 3C2x, sorry, 2C1x plus 3C2x squared plus dot 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 plus n plus 1 into Cn x to the power n. Now, from the whole equation, I need to replace x. I need to remove x. So what should we substitute in place of x? Tell me. I need x to be removed. What should we substitute in place of x?
Sir, there should be
Sir,
one
put
in.
x equal to 1, I think.
Right, Raktim. We have to put x equal to 1.
Sir, I was telling that there should be one n, that x into 1 plus x to the power n minus 1.
I have written it. Oh, acha, x. You are correct. X into n into 1 plus x. So over here, we need to substitute x equal to 1. Right, tell me. Devank, Anandit, and Raktim. Tell me, putting x equal to 1, what do we get? We get n into 2 to the power n minus 1 plus 2 to the power n is equal to C0 plus C1 plus 2C1 plus 3C2 plus 4C3 plus dot 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 plus n plus 1 Cn. Okay. So on the left hand side, what are we getting? Taking 2 to the power n minus 1 common, we'll get n plus 2. Hence proved. Is it clear, Shwamita, this method also?
Yes.
And Raktim, Devank,
Yes, sir.
Anandit, is it clear?
Yes, sir.
Which method was better, method 1 or method 2? Tell me. Tell me,
Method 2.
Raktim, which method was better? Which
Method
method you like? Method
sir.
2. Okay. So try number 11. Try number 11. Similar type. Yes, Socrates, the right answer.
Both of them, no? So both of them are correct, or you checked one?
Number 11 is correct. I'm checking 12. Yes, 12 is also correct. So should I start 11? Tell me. Anandit, Raktim, Devang, Shomita. Should I start 11? Similar type?
Minute.
So can I send? Wait, I'm sending you.
Okay, say. Yes, Devang, right answer. Yes, Shomita, your answer is correct. Devang, your answer is correct. Raktim, your answer is correct. I think only Anandit is left. Anandit, should I start? Hello, Anandit.
Sir, I'm solving it. Just give me 1 minute.
Oh, okay. Yes, Socrates, your answer is correct. Number 13. Hello, Anandit, can you hear me?
Yes, sir.
Anandit, how did you wrote NCR is equal to N by R into N minus 1 CR minus 1? How did you wrote this? Hmm? Anandit, can you tell me? Hello, Anandit, am I audible? Anandit, am I audible? Hello, Anandit, what happened? Am I audible to others? Tell me.
Yes, sir.
Dr.
Yes, sir.
Raktim, am I audible?
Yes, sir.
Anandit, am I audible? What happened? Do you sleep? I think you slept. Oh, acha. Is Shomita right answer? Okay, so who is left for 12? Raktim and Devang, should I start 12?
Sir, just
11,
12.
everyone has solved. Solve quickly, solve 12. Raktim, is it done? Why is it taking so long? Cannot understand.
Sir, I have sent it. It is going.
Okay. Yes, Raktim, your answer is correct. So I think only Devang is left. So Devang, pay attention. Devang, over here, there are two methods to solve. Actually, there are many methods to solve. Okay. So Devang, see. This is number 12. So let S be is equal to 0, C0 plus 3C1 plus 5C2 plus dot plus 2R plus 1. 2n plus 1, right? How much? 10 plus 1 Cn. Acha. So Devang, you tell me. Over here, the coefficients are in AP. Can you understand?
Yes, sir. Sir, I have
The-
solved 12. Can I send it?
Okay, what? You have solved it? Which method you have applied?
Sir, I've used summation method and I've splitted it. I'm showing you the method.
Okay.
I'm sending.
Okay, send. This is also another method. Everyone pay attention. You write summation in the reverse order. 2n plus 1 C0 Cn plus 2n minus 1 C1 plus dot plus Cn. So when you add S plus S will be equal to S. 2S will be equal to 2n plus 1 into C0 plus 2n plus 1 into C1 plus 2n plus 1 into C2 plus dot plus 2n plus 1 Cn. Right, tell me, Shomita, Devang, Raktim, Anandit, are you back? So when you take 2n plus 1 common, within brackets, you are going to get C0 plus C1 plus C2 plus dot plus Cn. Achha, what is C0 plus C1 plus C2 plus up to Cn? What is this? What is the value? Tell me, Shomita. Devank, what is the value? 2 to the power n, right?
2 to the power n,
This
yes.
implies S is equal to 2n plus 1 into 2 to the power n by 2, which is equal to 2n plus 1 into 2 to the power n. Hence proved. Last one, number 13, solve. Solve 13. Yes, Shomita, did you understand this method also?
Yes, sir.
Okay. Achha, this is what we needed to prove or something else?
Sir, n plus 1 whole to the power
Oh, it
2n.
was n plus 1. But why am I getting 2n plus?
So it will be n plus 1 only. When I got n plus 1 using my method.
Ah, yes. But why I'm getting this? Wait. Oh, when we add, it will be 2n plus 2, not 2n plus 1. Are you getting everyone? It will be 2n plus 2 everywhere. Ah, now it's fine. So when you divide, you are going to get 2n n plus 1 into 2 to the power n. Is proved. Okay, last one, quickly solve. Should I start everyone? Last one? There are two methods I'm going to show you. Pay attention. There are two methods. Oh, wait, what did I do? Okay, last one. Okay. So you people tell me over here, it is 2 into C0 plus 2 square by 2 into C1. So first of all, you write down the summation. So method 1, using summation. Okay. It will be summation of R equal to, I mean, what is the Rth term? First of all, write it down. Wait. Summation of r equal to 0 to n 2 to the power r plus 1 into NCR by r plus 1. Right. Too many things are given. Next. Now over here, let us understand what is NCR by r plus 1. So NCR by r plus 1, can I write it as n factorial divided by r plus 1 into r factorial into n minus r whole factorial. So r plus 1 into r factorial is r plus 1 whole factorial. So it will become n factorial divided by r plus 1 whole factorial into n minus r factorial. Okay. Now see everyone, what is the sum? N minus r plus r plus 1, that is n plus 1. So I need n plus 1 in the numerator. What I'm going to do is I'm going to multiply and divide by n plus 1. So this becomes 1 by n plus 1 into n plus 1 into n factorial upon r plus 1 into n minus r whole factorial. To convert it into a single binomial coefficient, this will become 1 by n plus 1 into n plus 1 cr plus 1. Tell me, did you people understand that NCR by r plus 1 is equal to 1 by n plus 1 into n plus 1 cr plus 1? Tell me. Shomita, Raktim, Devang, Anandit, is it clear?
Yes, sir.
Yes, sir.
Devang, is it clear?
Yes, sir.
So this will become, this whole summation will become summation of r equal to 0 to n 2 to the power r plus 1 into n plus 1 cr plus 1. Okay, divided by n plus 1. So whichever is the variable, take it outside. Taking 1 by n plus 1 outside, within brackets, you are going to get summation of r equal to 0 to n 2 to the power r plus 1 into n plus 1 cr plus 1. Okay. Now let us start. Okay, let us start expanding. For r equal to 0, it will be, for r equal to 0, it will be n plus 1 c1 2 to the power into 2 plus n plus 1 c2 2 squared plus n plus 1 c3 2 cubed plus dot 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 dot. For r equal to n, it will be n plus 1 cn plus 1 2 to the power n plus 1. What does it looks like? Tell me everyone. What does it looks like? Are you people able to
GP.
see NC1? GP. What does it looks like? Try to compare. NC1 into 2 plus NC2 into 2 square. Acha, wait. NC1 into x plus NC2 into x squared.
1 plus 2 to
Plus
the power n plus 1.
exactly. Are you people able to understand? But one term is missing. That is n plus 1 C0 term is missing. So I'm going to add and subtract n plus 1 C0. Tell me. Raktim, Shamita, Anandit, Devang, are you people getting? So this will become 1 by n plus 1. 1 by n plus 1 within brackets. 1 plus 2 whole to the power n plus 1 minus 1. Okay, I think this is what we needed to prove. This will be
Yes, sir.
equal to 3 to the power n plus 1 minus 1 upon n plus 1. Hence proved. Tell me. Shamita, Raktim. Raktim, is it clear?
Yes.
Devang, Anandit,
Yes, sir.
is it clear? Method 2. Okay, method 2. So everyone, let us recall this problem. Over here, the coefficients were in, I needed the coefficients in front. So I differentiated it, right? Because whenever you differentiate x to the power n, you are going to get coefficient in the front, n dot x to the power n minus 1. But now I need the coefficients in the denominator. Are you people able to see 2 to the power n
So
plus 1 upon n?
integrating this equation.
Exactly. Exactly. Do you think integrating will help us? What do you think, everyone? Do you think integrating 1 plus x whole to the power n will help us? That is c0 plus c1x plus c2x squared plus c3x cubed plus dot 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 plus cnx to the power n. So when you integrate both sides, Shamita, you know basic integration, right?
Yes, sir.
Integrating both sides. What do we get? We'll get integral of 1 plus x whole to the power n is equal to integral of this whole expression. Okay. So this would give us 1 plus x whole to the power n plus 1 upon n plus 1. This will be equal to c0x plus c1 x square by 2 plus c2 x cube by 3 plus c3 x to the power 4 by 4. Are we getting the result? What do you think? But in place of x, what do we need? Tell me, everyone. In place of x,
Like 2.
we need 2, right? So what if we integrate from 0 to 2? That will give us the result if I integrate from 0 to 2. Okay, so integrate from 0 to 2. Okay, anyone having any doubt, you can ask me. So what are we getting? 3 to the power n plus 1 minus 1 upon n plus 1. This will be equal to c0. When you substitute 2, you are getting c0 into 2 plus c1 into 2 square by 2 plus c2 into 2 cube by 2 plus dot 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 plus cn into 2 to the power n plus 1 by n plus 1. And when you substitute 0, all of them will be equal to 0 only. Hence proved. Tell me, has everyone understood this one? If there's
Yes.
anyone having any doubt, you can ask me. Tell me, Shamita, is it clear? Did you understand properly?
Yes, sir.
Okay. Raktin, Anandit,
Yes, sir.
Anandit, are you back? What happened? And Javang, did you understand this one?
Yes, sir.
Okay, another set of problems. Socrates, did you understand this method also?
Integrating the limits. I had a confusion with limits. I understood.
Okay. So another set of problems. Try them out. Okay. What was the last question number? 13 or 14?
13, sir.
13. Solve quickly. 14, 15. Should I start with 14? This is 14, 15, 16. 1, part 2, part 3. Should I start? First one,
So
everyone?
please wait.
Okay. Solve quickly. Yes, Socrates, your answer is correct. What have you done? Raktim cannot understand your proof only.
Sir, actually, I do 2-3 steps like C C0 plus 1 by C0 equal to 1 plus
When you
1.
multiply, wait.
Uh,
When you multiply, okay, 1 factorial into 2 factorial into 3 factorial up to n factorial will give us n factorial. Just check.
So So 1 second, check it.
Write the proof properly. Tell me, Shomita, Devank, should I start?
Sir, please wait.
So, Raktim, after the last step, after simplification, what are you getting?
Sir, actually, I was doing in like I was solving the every step like NC0 plus NC1 by NC0. Then I am getting like a pattern 1 plus n by 1 into 1 plus n by 2 into 1 plus n by 3. Like that I got.
Okay.
I was simplifying like C is not C0 by C0 plus C1 by C0 equals to 1 plus C1 by C0. Then I simplified it and got 1 plus n by 1, and the other part after simplifying I got 1 plus n by 2 like this.
Okay. And it keeps on going.
Yes, sir.
Okay.
Actually, after 2-3 step I did not solve further. I left it.
Okay. So, who is left? Shomita is left and Devank is left. So, Shomita and Devank, I'm starting. Okay, pay attention. Shomita and Devank.
Sir, I've
Yes,
said.
Socrates, 15 is correct. Shomita, Shomita, are you there?
Yes, sir.
Where are you getting? Seriously, from where are you getting n plus 1 whole factorial divided by r plus 1 whole factorial into n minus r whole factorial? From where are you getting this?
Sir,
What is
the
the law?
previous page I have not sent me.
Send fool. How will I understand? Okay. Okay, Devank, your method is correct. Okay. After simplifying the numerator, you started substituting, right?
Hello, sir. Can you hear me?
Yes, tell me.
Yes, you were saying something.
Yes, that's what I was saying. That uh, after getting the simplification n plus 1 CR plus 1, simplifying the numerator, you started substituting the value consecutively, right?
Yes, sir.
And then
Yes.
added.
Yes.
Okay.
And so the continued product step is correct. So
Correct.
okay.
Hello, Shomita.
Yes, sir.
Shomita, somewhere you wrote n plus 1 whole factorial divided by n factorial is equal to n plus 1. What was that? Hmm? Shomita? Shomita, you wrote n plus 1 whole factorial divided by n factorial is equal to n plus 1. Cannot understand how are you writing
Sir,
this.
n plus 1 minus 1, so it gives me n factorial and it gets cancelled. So n plus 1.
Oh, okay. Got it. 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 It's correct. Correct. Sakrit, your answers are correct. Okay. Acha, Raktim, I'm starting to solve number 14. Okay. I'll show you another method, Raktim. A better method of simplification. Okay.
Okay, sir.
So, Raktim, it is a continued product of r equal to 0 to n. R equal to 0 to n minus 1. CR plus 1 upon CR, right? Now, Raktim, what is CR plus CR plus 1? What is NCR plus NCR plus 1? Tell me. N plus 1 CR plus 1
Yes, sir.
upon NCR. Okay. Continued product. So this will become continued product of n plus 1 CR plus 1 will be equal to n plus 1 whole factorial upon r plus 1 whole factorial into n minus r whole factorial multiplied by r factorial into n minus r whole factorial upon n factorial. So this two gets cancelled by r plus 1. This two gets cancelled completely. This will go by n plus 1. Are you getting, Shomita? We could have simplified it directly like this. So it is continued product of r equal to 0 to n minus 1 n plus 1 upon r plus 1. Tell me, Shomita, are you getting?
Yes.
And Raktim, are you getting? You put r equal to 0, you are getting n plus 1 by 1 multiplied by n plus 1 by 2 multiplied by n plus 1 by 3 multiplied by dot 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 n plus 1 by n, which is equal to n plus 1 whole to the power n upon n factorial. Hence proved. Okay. Is it clear, Raktim?
Yes, sir.
Okay. Tell me, Shomita,
Yes.
Raktim. Okay, question number 15 I'm solving. Pay attention. Find the coefficient of x to the power 50 in 1 plus x whole to the power 101 into 1 minus x plus x square whole to the power 100. Okay, pay attention. This number 15. I need coefficient of x to the power 50. So I've got 1 plus x whole to the power 101 into 1 minus x plus x square whole to the power 100. So this becomes 1 plus x whole to the power 100 into 1 minus x whole plus x square whole to the power 100 multiplied by 1 plus x. Right, tell me. Shwamita, Raktim, Devank, are you getting? This becomes
Yes, sir.
1 plus x into 1 plus x cube whole to the power 100. This can be written as 1 plus x cube whole to the power 100 plus x into 1 plus x cube whole to the power 100. Right, tell me. Shwamita, Raktim, Devank, are the people getting?
Yes.
Okay. Now over here, can you ever get x to the power 50? Tell me. All the powers will be multiple of 3. Can you get x to the power 50? No. Over here, all the powers will be of the form 3k plus 1. Right.
Yes, sir.
All the powers of x will be of the form 3k plus 1. But when you divide, but 50 when divided by 3, what is the remainder?
Sir, 2.
Remainder is equal to 2. So can you get x to the power 50 in the second one also?
No, sir.
No. Hence, what is the coefficient of x to the power 50?
0.
So can I please scroll up once?
Yes. Tell me. Devank, is it clear?
Yes, sir.
Shwamita, Raktim, Anandit, is it clear?
Yes, sir.
Okay. Try out 16. 16 is very easy. Don't tell me that you cannot solve 16. Okay, should I start? What happened with 16 part 1?
Sir, 1 second and sending altogether.
Send. How will you get A0 plus A1 plus A2 plus up to A2n? How will you get sum of all the coefficients? What should we place in place? What should we substitute in place of x?
X equals to 1.
Correct. Substitute. Send. It is very easy. It's all about substitution. Nothing else. Yes, Raktim, your answer is correct. Okay, I'm starting. Okay, I think they won't pay attention. 16 part 1. Putting x equal to 1. We'll get the result. 1 plus 1 plus 1 whole to the power n is equal to A0 plus A1 plus A2 plus A3 plus up to AN. Okay, this implies A0 plus A1 plus A2 plus up to AN is equal to 3 to the power n. Part 2. Part 2, Devang and Shamita, what should we substitute?
Minus 1.
Minus 1. Right. Then why are you people not sending?
Sir, I'm doing all of them and then sending.
Oh, acha, send. Send after this third part, I will not solve, we will send it. Okay, which is equal to 1 to the power n. Shamita, see what we needed to prove and what you proved. See, Shamita.
Yes, sir.
Rectify quickly. And Devang send.
Yes, sir. Please.
Anandit, are you back?
Yes, sir. Sir, I'm sending all three at once. Is it all right?
Yes, send quickly. Your laptop is fixed now.
Yes, sir. It's an old laptop. The charger is having some problems.
Try to use a proper device if possible.
So we need to subtract.
Of course.
Sir, I've sent part 3.
Yes, part 3 is correct. Okay. I'm sending some more.
can you please show the part 3 once again?
Part 3.
Yes. I mean the question.
Yes, Socrates, are you solving the rest?
Yes, sir.
4, 5, 6, 7. Yes, Anandit, your answers are correct. Saktim, part 4 is correct. Shomita, part 3 is correct. You have to subtract. Start solving, everyone. If you have done part 3, we have part 4, part 5, part 6, part 7, and part 8. Devang, part 4 is correct. Part 4, everyone must have solved.
Sir, I did it before only.
Of course.
So can you once show the expression?
Yes.
No, sir. Part.
Wait.
Yes, sir. Done.
Sir, I've sent to part 5 and 6. So we can't hear you, I think.
Hello, can everyone hear me?
Yes, now we can hear you.
Yes, sir.
Okay. So what you have to do is over here, the whole idea is to interchange the variables. Okay, like the a0 should be the coefficient of x to the power n. A1 should be the coefficient of x to the power n minus 1. Then only we can compare and say that a0 equal to an, a1 equal to an minus 1. Are people getting? Tell me the approach. Tell me, Raktim, Anandit, Devang,
Yes, sir.
Shomita, are you people understanding the approach? Tell me. Tell me. Devang,
Yes, sir.
Anandit, Raktim, are you understanding? Okay. 1 plus 1 by x plus 1 by x square whole to the power n. This will be equal to a0 plus a1 by x plus a2 by x squared plus a3 by x cubed plus dot 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 plus an by x to the power n. Now what you do is to multiply by x to the power n on both sides. Multiplying by x to the power. Wait a minute. Was it a2n x to the power 2n? Wait, let me see. In the question, it must be a2n x to the power. Yes, it was a2n x to the power 2n. I am taking an only. So it should be a2n x to the power 2n. So multiplying by x to the power 2n on both sides. Okay, multiplying by x to the power 2n on both sides. What do we get? X square plus x plus 1 whole to the power n is equal to a0 x to the power 2n plus a1 x to the power 2n minus 1 plus a2 x to the power 2n minus 2 plus dot 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 plus a2n. Now if you comparing 1 and 2, comparing equations 1 and 2, what do we get? We get a0 is equal to an, a1 equal to an minus 1, a2 equal to an minus 2, dot 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 dot, ar equal to a2n minus 2r. Sorry, a0 equal to a2n. Tell me, Devang, is it clear?
Yes, sir.
2n minus r. Hence proved. And Raktim, Anandit, Shomita, is it clear?
Yes, sir.
Yes, sir.
Okay. Should I start part 6? Tell me. Part 6 is very easy. a0 square minus a1 square. What else you need? You have to think, how are we getting a0 square minus a1 square? Okay, so everyone see. What I'm going to do is, this is equation 1 and equation 2. I'm going to multiply equation 1 and equation 2 for part 6. Multiplying. Acha, wait, no. You've got 1 plus x squared whole to the power n is equal to a0 plus a1x plus a2x squared plus dot 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 plus a2n x to the power 2n. what you do is you replace x by minus x. Okay, this is the equation 1. Replacing x by minus x. What do we get? We get 1 minus x plus x squared whole to the power n is equal to a0 minus a1x plus a2x squared minus dot 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 plus a2n x to the power 2n. This is equation 2. Equation 1 multiplied by equation 2. What do we get? Okay, we are going to get 1 plus x square whole to the power n multiplied by 1 minus x plus x square whole to the power n. So somebody multiply and tell me what will you get? I'm
So
multiplying the
A,
right hand side. What?
we are getting an as the coefficient.
An is the coefficient. I'm asking you to multiply these two expressions.
Oh, wait, sorry.
It's a class 7 problem. You people have done it in class 7. Multiplication of two algebraic expressions. Tell me.
Sir,
I'm
x
multiplying the
square
right hand
plus
side.
1 whole square minus x square to the power n.
What?
Sir, x square plus 1 whole square minus x square.
So simplify and tell me. I need the simplification. Okay. Okay, on multiplication, we are getting this. Actually, it should be with minus, then plus, then again minus, then at least lastly it is plus.
X to the power 4 plus x square plus 1.
X to the power 4 plus x square plus 1. Very good. Tell me. Now we have to compare the coefficients. Tell me. Which term? I mean, we should compare the coefficient of which term? Tell me. We should compare the coefficients of which term? Remember, AR is also equal to A2n minus R. So you are safe. You just need to understand how are you getting A0 square. Okay. Plus dot 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 dot. Lastly, we are getting A2n x to the power 2n multiplied by this. Okay. So everyone, how are we getting A0 square? A0 square is A0 into A2n, right? Coefficient of x to the power 2n. Let me see. A0 square. But I need A1 square also. A1x into A2n minus 1. A1 square. So I think x to the power 2n. Are you getting everyone? We need to compare the coefficient of A0 square minus A1 square. So we need to compare the coefficient of x to the power 2n. So everyone, let us compare the coefficient of x to the power 2n. Okay. What happened? So everyone, over here, what is the coefficient of x to the power 2n on RHS? Tell me. What are you getting? It will be equal to A0 into A2n minus A1 into A2n minus 1. Okay. Plus A2 into A2n minus 2. Okay. Minus dot 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 dot. Which is equal to A0 square minus A1 square plus A2 square minus A3 square plus dot 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 dot. Tell me. Shomita, Raktim, Devang, Anandit, are you people getting?
Yes, sir.
Socrates, are you getting? Hello, Socrates, are you there?
Yes, sir.
Are you getting coefficient of x to the power 2n on the right hand side.
Hmm.
A0 square minus A1 square plus A2 square minus A3 square dot 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 dot. And Sakrohit, tell me what is the coefficient of x to the power 2n on the left hand side? This is nothing but 1 plus x square plus x to the power 4 whole to the power n. So tell me, Sakrohit, what is the coefficient of x to the power 2n on the left hand side? It is same as coefficient of x to the power n
X to the power n in this initial expression.
in the initial expression, right? They both are same.
Yes, because you are just getting one like a square of the powers.
Exactly. So tell me, and coefficient of x to the power 2n on the left hand side. What is it? Tell me. Tell me if I want to find out the coefficient of x to the power n,
So that is an itself. Done.
an done is equal to an. Hence proved. Okay, 5 is done. No, this was 6. Okay. Should I start 7? You need to understand how are you getting A0, A1, A1, A2. Tell me. Should I start? Okay. So Devank, Raktim, Anandit, pay attention. A0, A1 minus A1, A2. So let us look at this product only. Okay. Let us look at this product. How are we finding A0, A1, A1, A2, and so on? So A0, A1, A1, A2. No, not this one. Acha, let us look at from the right hand side. Okay. A0, A1 means an A2n minus 1. That is the coefficient of x to the power 2n minus 1. Next, A1 into A2n minus 2. That is the coefficient of x to the power 2n minus 1. Right. So we need to compare the coefficient of x to the power 2n minus 1. So part 7. Coefficient of x to the power 2n minus 1 on the right hand side. Right, Shomita, are you able to understand how I am approaching the problems? It is very important. If you don't understand, you won't be able to solve it at home. That is A0 into A2n minus 1 minus A1 into A2n minus 2. Okay. Plus A2 into A2n minus 3. Dot 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 dot. Raktim, Anandit, are you getting? Which is equal to A0, A1 minus A1, A2 plus A2, A3. Dot 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 dot. And what is the coefficient of x to the power 2n minus 1 on the left hand side? Tell me. What is the coefficient? What do you think? What do you think is the coefficient of x to the power 2n on the left hand side over here? Can somebody tell me? It's common sense. Tell me. Sakrohit, Devank, Anandit, Raktim.
So can you repeat the question once?
What is the coefficient of x to the power 2n minus 1 on the left hand side? On the right hand side, we have already got this. Right, Sakrohit?
Hmm.
On the right hand side, we have already got this expression, which we were supposed to find out in 7. Now I need the coefficient of x power 2n minus 1 also on the left hand side to compare. What is the coefficient of x power 2n minus 1 on the left hand side? Tell me. It's common sense, everyone. Common sense. It's very simple. What is the coefficient of x to the power 2n minus 1 on the left hand side? 1 plus x square plus x to the power 4 whole to the power n. Can someone tell me? Shomita? Tell me. I'm audible, right? Everyone? Devang, can you tell me what is the coefficient of x to the power 2n minus 1 on the left hand side? I think I have to check my internet connection. What happened? Nobody is speaking.
So we can
Am I
hear
on?
you.
You can hear me, right? You have it's dead silence. I don't know what did I ask. What is 2n minus 1? 2n minus 1 is odd or even?
Sir, odd.
Odd.
Oh,
Odd.
will you get an odd power over here?
0, sir.
0. Right. That's why I said. Look at it properly. It's clear observation. Okay, so hence, you people understood, right? Or should I explain again? Tell me. Plus A2, A3, dot will be equal to 0. Tell me. Rakshim, Anandit, Devang, Sokrit, Shomita, is it clear?
Yes, sir. Clear.
Yes.
Okay. Last one, let me solve it. Part 8. I'll just look at the coefficients. Coefficients are A0, A2. Okay, so A0, A2. Let us see. So everyone, pay attention carefully, okay? A0 and I need A2. A2 is the, okay, A2 or A2n minus 2. So everyone, A0 and A2n minus 2 is the coefficient of x to the power 2n minus 2 only. So A0, A2, x to the power 2n minus 2, A1x into A2n minus 3. That will give us x to the power 2n minus 2. So that means we need to compare the coefficient of x to the power 2n minus 2. Right, everyone? In this equation, okay, in this equation, okay, in this equation, call it equation 3. In equation 3, A0, A2, A1, sorry, A1, A3, A2, A4 are all coefficients of x to the power 2n minus 2. Okay, so what is the coefficient? What is the coefficient of x to the power 2n minus 2 in LHS? Okay, I'll make it a bit easier for you people. You can write x to the power 2n minus 2. You can write x to the power 2n minus 2 as x to the power n minus 1 whole squared in LHS. So somebody tell me quickly, what is the coefficient of x to the power 2n minus 2 on the left hand side? Means x to the power n minus 1 whole square. Okay. Compare it with the original equation. I need x to the power n minus 1. Remember, that is the coefficient of x to the power n minus 1 in the original equation. You people tell me, what is the coefficient of x to the power n minus 1 over here? What is the coefficient of x to the power n minus 1 over here? Tell me.
A n minus 1.
It's a n minus 1. Tell me, everyone, it's not too much, right? You people are able to understand, right? Tell me. Which can also be written as a n plus 1. Hence proved. Tell me. Raktim, have you understood? If you didn't understand, you ask me again. Tell me, Raktim.
No, sir, I understood.
Understood properly?
Yes, sir.
It's not too much, right? Understood? It's not a bouncer, right? Tell me.
No, sir.
Okay. Anandit, Devang, understood properly? Tell
Yes,
me.
sir.
Yes, sir.
And Shaumita, properly understood? Tell me.
Yes, sir.
It's not too much. You are able to understand, right?
Yes, sir.
Socrates, is it clear?
Yes, sir.
Okay. Okay, so everyone, I think we can keep it till now. Next class will again continue. Okay. Very soon I'll be completing binomial. Okay. Thank you, everyone. And good night.
Good night, sir.
I'll send everything what's. Thank you and good night, everyone.
Thank you, sir.